In this video, we have transferred our code from the last video into our time series module that we'll show you here in a second. In this video, we'll use this function, the data that it reads, in order to help us develop a new function called MA that stands for moving average, that will help us visualize or kind of see what's going on with some time series type data. And finally, the last thing I want to do is introduce matplotlib. So you'll see it right here, matplotlib. So in addition to creating this moving average time series function, we're going to introduce a way to visualize it. So that's the plan for today. Let's open up Spyder and go. So right now, I'm going to go from time series import read CSV. So in this folder that we're in, AY21, if I open up this thing, you'll see that I can kind of go through here. We're in this AY21 folder, and there is no time series.py. So where is the time series py at? It's in documents, Python modules, in this sucker right here, the one that I think it was the first video, we made this in the path, and you can see where right here where it says module folder, this thing is in the path. And so we're able to use this time series module here and grab any function that lies in it and use it in our code. So we're going to grab the read CSV code or function that we created last time. So I'm going to just hit F9, and now, even though you can't see anything over here, we can now use this sucker. Now the question is, where's this AMZN? So let me open this, not this. If I open up a thing, you can see the AMZN data file, the CSV file, comma separated value file is in the folder that we're currently in. So that has to be in the folder that you're in. Otherwise, you have to tell it where it's at. So if I hit F9, oh yeah, so I changed this to date underscore date. Try it again. Yeah, I changed the date format to be according to PEP8. Remember, it said to use the underscore and all that business. And so in the past, when I've coded this, I would use date and then capital F. But from now on, I'm going to try to use PEP8 in my coding. All right, so now we have that information in there. So you can pump this guy up, and you can see there's a date time. You have all the floats, and so we've seen this before already. But now I'm just showing that I'm using this in anywhere in my computer. I can just pull up from time series, import read CSV, and we can use this guy. So we have that going for us. And now what I want to do is I want to create this moving average. I put it time underscore series, TS, they mean the same thing. And the N here is the number of elements that I'm going to use in order to do the average. And basically it talks about what it is. It calculates the moving average of n days, returns a series with n-1 elements, blah, blah, blah. So let's just jump down here to the example. So I'm going to pull in a time series, I'm going to pull in an n. So let's just say that the time series is the numbers 1, 5, 3, 2, 6, 5, and 4, and my n is equal to 3. And so right away, I know I'm going to have n-1 less elements, so I'm going to have 2 less elements now. So at the end of the day, I better have a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So I had 7 elements go in and only 5 come out. Just realize that has to happen because we have to have a certain amount of initialization of this new series. And here's why. Because what I'm going to do is the first step is I'm going to take the first 3 numbers and I'm going to add those together or average them, which is what you have here, and that becomes the first number in your time series. Here, let me use this. No, it doesn't do anything extra. So 1 plus 5 plus 3 divided by 3 gives you 3. And then the next one is the reason why it's called moving average is you step in the next direction, the next 3 numbers, and those would be the next 3 numbers. And you divide by 3, you get 3.33, and that becomes your next number. And then we move to the next 3 numbers over, 3, 2, and 6, and that leaves and divide by 3 gives you 3.667, and so on and so forth. And you can see that's how it ends up being two less numbers, because I need these first two numbers. I'm not doing anything with them, but then you get to the third number, the n is equal to 3, and that's when you can start producing numbers in the series. Okay, so if that's the case, then now what I want to do is let's go ahead and start producing some code. So the first thing that you might want to do is maybe find the length. So I call it little m. TS, because if this were an A and M by N matrix, N would be the number, M would be the number of rows, and that's why I like to use that. And then MA is going to be the thing that we're going to return. So right now it's just a blank matrix, I'm sorry, a blank list. And then if N is greater than M, we got to say something. Let's probably return, get out of it, just say, hey, you can't do it, not possible. So that's not possible. If you have if I have 3 elements, I'm trying to do an n is equal to 15 moving average, that just doesn't make any sense. So that's where that comes from. And then next thing I'm going to do is go for I in range, and then I want to go from m, which is the total. I'm going to subtract n, and I'm going to add 1 back. And sometimes you have to discover why you have to add 1 back. Do it without the +1 and see what happens. We're going to do a little bit of testing here. And the way I'm going to test it is I just want to print series. I'm going to go from I. So I'm just going to start off like this. Press F9. And now what we got to do is we got to get some data. So my first idea is just to use the data that we already had. Well, the problem with that is it's in this matrix form, and so I'm going to pull it out and just get one piece of data. So we're just we'll call it test data. Test data is equal to, and you got to do some list comprehension here. So data I. So the first one is the row. So I would be 1, 0, 1, 2, 3. Yep, that's right. And then I want the first column. Because the 0th column is the date, right? So if I pull this up and then pull one up, I'm getting the first column would be the closing price, the second column would be whatever that thing is, and so on and so forth, and that would be the volume. Okay, so T of data. And then you open up test data and you make sure that you have this thing that you think you have. So 81.85, 85.375. So let's see if the second one it is, and the third one 70.1, 7.5, and it is. Okay. And then the next thing, we're going to need this here in a second when we plot it. I'm just going to go ahead and get it out right now. And the dates was in 0. For I range length. So this should be all the dates that we're interested in, except for, oh, I forgot that. So, but remember, you can't break your computer. So if you forget something stupid, or it's not necessarily this has to be perfect the first time you run it. And it looks like it's all the dates that we're interested in. Okay, so we're going to need that here in a second when we go to plot. And now let's print test underscore data. I'm not going to print all, 5,134 of these suckers. I'm only going to go from 0 to 20. And so that gives us our first 21 pieces of data. And that's what I'm going to use to test my function with. So MA test data 0 through 20 is what we'll pass in, and we'll let n equal maybe 5. Okay, so what I want to do is just make sure that it's doing what we think it should be doing. So the first one should be grabbing the first 1, 2, 3, 4, 5, and it is doing that. Yes, you can kind of see, compare these numbers to the first 5 pieces in your test data, and then make sure that the second one is the second 5, right? So in other words, it's these 5. So it drops the first one and then picks up the last or the next one, and it looks like it does it. So you compare those should all be the same, and the next one is 72, and you can see 66.875 and the rest of them. So you can kind of see what's happening. That's why I didn't want to go ahead and do the average, because maybe if I were to calculate the average here, it wouldn't be so obvious. So it might not have been so obvious. That let's just make sure that we're getting 60.375, and it looks like we are in the last 5 digits. 65, 65.185. Okay, so it looks like it's doing what it's supposed to do, or at least it's grabbing the right things, right? And then we can count these and make sure that it's 5 minus. So it's 16 plus 1, so it's 17. It's probably 17 of these things. We could just make sure that that's happening as well. But here's what I want to do. And I had to discover this actually doing this method. If I take out a +1, is that where? Yeah. If I take out the +1, let's check out what happens. So it looks like it works, right? So it starts at 81, it goes to 67, and it looks like everything works except for what happens here. This guy stops at 65, and it doesn't get the last one. That's why I knew I had to come back in here and add the +1. That's it. I mean, sometimes you have to experiment with these things, and maybe it doesn't make a whole lot of sense, especially with these 0-index languages like Python. Sometimes these things don't make sense. Maybe in R, where it's a 1-index language. And remember what I mean by that. 0-index means it starts. So Python's indices start counting at 0, and that means they go to n-1. R starts at 1, so its first element in a list is the 1th index instead of the 0th. So usually those are a little easier to do some things with, and sometimes the 0-index ones are easier to do stuff with. Okay, so let's go ahead and run this one more time to make sure that I didn't introduce a bug, and this is going to 60.37. Okay, so everything looks like it's right. All right, now I'm going to come back in, and we are going to input in. Oh, we already did. Never mind. We already got. So I have MA already. It's just telling you right now you never used it. So hey man, you got to use this bad boy. I'm gonna get rid of that. I'm gonna say MA dot append, and we will append the sum of these, right? So I'm going to add up all of these cats here, put them inside there, and get outside the sum and divide by n, and that'll be my data. And then we want to return that sucker. Once I'm done going through all of the pieces, then I'm going to return, if I can spell return right, return MA. All right, let's do this. So now we have 75.1. And so the proper thing to do right now is to go up and get your calculator out and calculate the average of that. Or you can come up here and do it inside here. So calculate that average. I can look at it and tell 71 is about right. So 75. Let's make sure. 75, yeah, 75 looks about right. And then down here, it's getting smaller. So 65-ish. Yeah, so 65-ish. Okay. The proper thing to do is to make sure that that is the number for those 5. I mean, you should get your calculator out and validate that when you're testing these things. All right, and so now what I want to do is I want to do MA over the entire thing. So test, and I'm going to set it equal to moving average to MA test. Yeah, and I'm going to put a capital N here, and we're going to let N equal 5. And then let's see. And so import. So we're going to import a new library that we haven't talked about yet. It's called matplotlib. Matplotlib and edit.pyplot. So this is the standard PLT. It's the standard way to import matplotlib. You will see this all over Python code. Python doesn't have a way to plot all by itself, so it needs this matplotlib.pyplot. And this comes from MATLAB. So this is So what it tried to replicate was exactly the same thing that you can do in MATLAB for Python. So that's the idea behind Matplotlib, is that you have the same exact, in the sort of the way that you plot two things is the same way you would do it in MATLAB. The way you would plot subplots and do multiple plots on one graph is the same way you would do it in MATLAB. And so that's the idea behind Matplotlib, is to sort of replicate for those who were coming from MATLAB so they could replicate the stuff in Python. Okay, so we have that going for us, and then what I want to do is go ahead and plot. So plt.plot is the command, and then I'm going to do, we don't have to do dates first, we can just do moving average. What the moving average looks like. So highlight the whole thing, and we get the moving average. Now, the idea of the moving average is to, and you can see it goes from 0 to 5,000. That doesn't help us out at all. So the reason why I'm going to add the dates in here. So you can see that I grabbed the dates out of here, but the problem is these dates are more, there's more elements in here than there is in the moving average. So what we have to do is put in dates, and then go from n, what is it, n-1 to moving average, or up. All the rest of them, that's what the colon means, and comma moving average, and let's find out what that does. And so now what you have is the year, so it's giving you 2000, 2004. So you can see Amazon's run started in about 2015, it looks like it's 2015ish, and then it just kind of exploded after that. So if you would have bought, you know, down here in 2008, maybe right after the last thing that happened to the economy, if you would have bought in there, you would have lots of money right now, right? So, but that's the moving average. And the idea of the moving average is to smooth this thing out. And this thing's not real smooth right now. So maybe we do 500. Let's see if it gets a little smoother. And there you go, right? So the more elements that you bring in, the smoother this thing will become. So that's the idea behind it. And you can see, obviously, if it takes 500 of these suckers to get warmed up, then you lose some of the data at the very beginning. What if I wanted to put two plots on the same graph? So plt.plot, and the actual data. So test data n-1 to the end, and then I'm going to change the color. We'll change the color of the data to be red. And this thing called plt.show, I don't think you probably don't have to do it, but that's technically what you're supposed to do. All right, so you can see how crazy the data is. It's kind of going up back and forth because these are all days. And then you can see the blue line sort of smooths out that data, and you can see it's underneath right now of where because it's 500 days, right? Because it's a time series that's moving up, and I'm using 500 days, so it's always going to be underneath it. So that's the idea behind the moving average. Okay, well, that's all I got for this lesson. Hopefully you're able to get something out of it. You understand that we introduced Matplotlib for the very first time. Haven't really had you guys think about that yet, to how to plot the data, but I thought it was appropriate for at least this particular lesson to start talking about that. And you can see how I went through one iteration of developing this new function this idea of this new function, in looking at the data first before, in a very small subset of that data, in order to sort of develop this thing and make sure that it's doing what I think it should be doing. All right, I hope you got something out of it. I'll see you next time.